What
Sure.
sparked really the idea behind the electroactive membrane?
So I was a graduate student at Duke in North Carolina. I was taking a class with Carl Linden. So this is 2006, and he was the class. I can't remember the name of the class at this point. It was, almost 20 years ago, but it was a great class. And the in the end, we could either write a paper or do a project. And I decided to do a project, and I was very interested in I'm actually a biologist in my undergraduate training, and then I was always very interested in biofouling and biofilms and things like that. And I had run across this old paper. This is going back, I believe, it from 1989, from Japan, and they were showing these, the intake pipes for power plants. I think it was nuclear power plants that they have over there, and the intake pipes get covered. They're in the ocean, and they get covered in barnacles and whatever else grows down there, algae, things like that, just like ships. And it's obviously a problem, that clogs the pipes. And their solution was to essentially electrocute or add a voltage to these pipes. And they added a low voltage. I can't remember exactly the details, but they showed us comparison side by side, a pipe that was not electrocuted and a pipe that was, and it's a clear difference. It's just dramatic. Nothing grows on it. Turns out the bacteria and other organisms, much like humans, don't like to be electrocuted. And that's being very simplistic, but reality is that it works, and it's very simple. And it was right around the time, so 2006 was right around the time that you could start buying carbon nanotubes commercially. So I approached Carl Linden, Professor Linden, and I asked would he give me the money to buy a gram of carbon nanotubes. It was $1,000 a gram. By the way, now it's about a buck. Buck, what is it? $1.15, something like that. You can buy a gram.
Yeah.
Something like that. But then it was $1,000 a gram. So I got this vial full of 1 gram of $1,000 worth of carbon nanotubes, and I made a first membrane just by filtering it. The carbon nanotubes. I had no idea what I was doing. And I made this little disc, about this big, and added some rinky-dink electrodes to it, and sort of showed that you can actually do some filtration through it. And that's kind of where it ended for a few years, and my research went in a different direction. And then when I was about to graduate, I did a few months as a postdoc with my PhD advisor at the end of my PhD. And I asked him, hey, do you mind if I just run with this a little bit more? And I worked with another graduate student at the time, Charles Delanoy, and this was at Mark Wisner's research group. I was a student at Duke, and so Charles and I worked together for a few months and made the first reverse osmosis conducting membrane. And it was really complex, and we tested it. Charles did a lot of the legwork on this, actually, and he actually did the experiments, and we showed that, yeah, it totally worked. It prevented, we were looking at biofouling on the surface of the membranes, and it worked. It worked really well, and we had no idea why exactly, but we published our first paper, and then actually I was in my lab. I was a brand new professor at UC Riverside, and there was a visitor from Israel, Moshe Hertzberg, is a good friend of mine, and he showed. The first time I met him, and he showed up in my lab, and I was just storing my stuff, my toys. Right, I was literally brand new. It was just a few months into the job. I don't think I even had any students yet, and I was telling him what I was going to be working on, and I mentioned this, and he said, "Oh, somebody just published this really nice paper on this idea." I was like, "Yeah, that was me. That was my paper." And
Oh, you read that?
yeah, and he looked at me, and I was like, "Yeah, I think I'm going to continue working on it." And he looked at me, and he said something that is seared into my mind. And he said to me, "What do you mean you're going to keep working on it? You're going to hit this until dust comes out." And, and I was like, "Okay, that's good advice." So I just started working on it, and sort of, it was a little bit of a blank canvas at that point. There wasn't, it was me, and there was Chad Vasides at Harvard, who was working on similar concepts, actually very similar. He was working more on like ultrafiltration of flow through electrodes. I was looking more on reverse osmosis and nanofiltration membranes and dense membranes. And he was more interested, I think, in like using the membranes to transform pollutants and things like that, which is work that has evolved dramatically. I was more interested in the membrane performance of the materials. So we worked on different aspects of this and demonstrated in a couple pilots, and started to really chip away at the mechanism behind what we were seeing. And it was really rewarding because, like I said, nobody really was working on this area. A lot of people thought it was kind of not, they couldn't really understand the utility of it, but the evidence was very compelling that we saw in the lab. I mean, it's a very simple system in its base. Once you understand what it can do and how to put it together, it's actually incredibly simple. And of course, there's a lot of learning pains and a lot of growth to that point, but it's really a remarkably flexible platform that you can, by simply tuning the voltage that you apply, essentially, you can drive so much chemistry and so much physics that it really just kind of opens up this wide range of applications.
And how did you recognize that this will change the desalination industry and market and everything?
Well, that's to be determined yet, but I'm hoping it will. But because I think so we did a lot of work originally on biofouling, like I said, and we kind of figured it out. And of course, being an academic, I didn't talk to anybody in industry. And then once I actually started talking to people in industry, they're like, yeah, we kind of figured out biofouling. Like, we know how to do it. It's not you got to manage it. It's pre-treatment and things like that. But there's solutions. And then somebody actually. It was a fellow who worked for NL, Norman Lee, one of his guys who passed away a few years ago. Unfortunately, he was a great guy, and he actually started talking about scaling, and he said, this is really the problem for a lot of these desalination processes, and Maxwell Tsai, that was his name, great guy, really sweet man, but he unfortunately passed away a few years ago. And so that got me thinking about scaling. And again, our first work was on nanofiltration, and then really when we started working on membrane distillation, which was late, I don't know, 2018, 2017, Department of Energy was investing some money into this area, so jumped on that bandwagon. And thinking about brine desalination, things like that, and that's where scaling is really an issue. And so that's where we really kind of developed the science behind what we were seeing, and recognized that actually by inducing electrophoretic mixing, by applying alternating voltages, potentials, we could actually really basically eliminate scaling under most conditions. And at that point, we filed our patents. We had a composition of matter patent on the membranes. We had some, application patents or process patents. And honestly, at that point, I was like, okay, this either, I know we can't swear here, but we either, it either goes into industry or not, because the research was largely completed. In fact, the last piece of research I think was published this year, was really developing a model to capture the ion motion that's induced from the polarity reversals, and that puts a nice framework around this. So it was time for it to go to industry, and then happily RN came around, and off to the races.
So what was the biggest sign from the industry where you thought, that's it, now we go all in?
Actually,
Was there any sign? I mean, everything was very academical.
It was very academic. I actually I was working with a pharmaceutical company, not a pharmaceutical, a medical supply company called Baxter, and we were doing some work on dialysis, and making. We were interested in making membranes for home dialysis systems, and one of the stages in the process in this project was to actually test the membrane at a large scale, and I designed this absolutely gigantic flat sheet membrane. Completely impractical, and we never got it to work. It was always leaking. We could never get it to seal properly because this thing was like almost a square meter or something. It was just huge, and we couldn't get it to work to seal properly. So then I said, forget it. We're just going to make a spiral. So I reached out to some folks in Orange County, in San Diego, and Gil Dewan, and we rolled up there, and they helped us roll our first module, and Arian was there, and we called that the Porcupine, and it looked like it just had wires sticking out of it, but it worked. That was the crazy thing about it. It actually worked, and we were able to show that we were able to stop membrane scaling on this little it was a small module, but it was spiral wound and had the form factor that would be amenable to real systems. It fit into a conventional pressure vessel for RO membranes, and it just it actually functioned the way we wanted it to. So I think at that point it was sufficiently de-risked to warrant the next step, which is raising money and trying to actually commercialize.
Sure. So as the brain of that, right? So how do you see that in, I don't know, in 10 years from now? How will this change, or what is your vision of that? How would that change the water industry in the next decade?
So for me, I just have to say that for me, it's really fun to see something that started off literally, as a little disc, now being manufactured, very large scale. It's been a long time, and it's been a lot of work, and so it's very rewarding to see that actually taking place, and having Ariane steward the process is just it's exceptionally lucky. I've worked with a lot of folks in industry, and Ariane is just fantastic. He just I can't think of a better person to shepherd this into the next stage. So I'm very fortunate about that. And I have to say, like, how you asked, how is this going to change the desalination industry? I don't know. I have no idea. I hope it gets adopted because it does have utility. It does actually have. It can unlock the desalination potential of more complex streams of and I think if you think about economics here, I think really where this has a really kind of a unique niche is brine minimization, right? So it doesn't matter what desalination process you're talking about. I don't care what you're trying to desalinate. Using active membranes, you'll just generate less brine. And if you're thinking about the cost, that's really where we have an advantage, I think, because we can actually operate in areas and under conditions that even anti-scalants fail. Like you just can't push the system that far, the recoveries that far. So that's really, I think, where active membranes have a pretty unique advantage right now. So I was very fortunate to receive support from various federal agencies. The first agency that supported the work was actually the Air Force, U.S. Air Force. And but then there was more support from Department of Energy, National Science Foundation, and Department of Interior, and throughout all of these efforts, an advisor can only take so much credit. Really, the boots on the ground, the people who actually did the work are students, graduate students, and postdocs. And I was incredibly fortunate to have incredibly talented students and postdocs working with me on this, and it really, without their efforts, it wouldn't have happened. So my first two graduate students is Wenyan Duan and Alexander Duchenko, just phenomenal engineers. Wenyan's now a professor in Yunnan in China, and Alex was working for the Department of Energy, and
I didn't know Alex was your student.
Yeah, he was my first
like
student.
him a lot. Yeah,
Alex is great. And so they really kind of took this off. Actually, when Jan did the first study on anti-scaling in 2017.
Yeah, nice.
Or maybe it was 2014. I don't know. And then after that, I had students like Unati Rao and Bongyang Jung, who just continued working on this. Avner Ronen was a postdoc with me. He did some really good work on membranes as well, on the biofouling side of things. It was really Unnati who did the first work on membrane distillation and kind of recognized the opportunity there in alternating currents. But it was Alex who, Alex's work, engineering work, led to active membranes, the manufacturing of the way we do it right now, because he's so talented. He took apart a printer, like a little laser printer, and reconfigured it and wrote code and built robots and did all this stuff and really made the first membrane manufacturing line, if you will, in my lab.
Okay.
So it was really it was his effort that kind of really took it to this next level where we could start thinking, okay, this is actually scalable. It's not just something that we make at a very small scale, but I could see through his eyes how you could actually make this much larger. So and then of course Yiming Liu is my most recent student who graduated last year or 2 years ago now, who kind of wrapped up the work on membrane distillation and put together that model actually that describes the physics around the electrophoretic mixing. Yeah, I've just been incredibly blessed working with just a great group of students and postdocs, and yeah, it's been a real pleasure.
And super international, right? I mean, I just
Oh, yeah.
hear the names, and the names come, what I hear, from all over the world.
Yeah, absolutely.
Crazy.
Yeah.
Well, it truly is an international project. Right now, it's interesting for you to know that in active membranes, a team of 8 people, there are about 8 languages spoken.
Crazy.
8 native languages.
Honestly, that's the beauty of desalination, working on desalination. It's just
Exactly.
all cultures, all nations, everybody's interested in it. It's really rewarding. People find meaning in the work beyond just, the degree or whatever.
Yeah.
So it's, I think it's a very rewarding environment to be part of.
Exactly. It's beyond what pigeonholes us as humans, nationality, race, sex, whatever. It's beyond all of that. It's, it is truly a boundless endeavor.